A geometric progression, or geometric sequence, is a number sequence where each term after the first is found by multiplying the previous one by a constant value. Geometric sequences can be found in many places, including nature, music, technology, economics, and art. They have been examined and used by many mathematicians over the centuries, first studied by a man known as Archytas. Born in 428 BC, Archytas was an ancient Greek philosopher and mathematician. He is believed to be the founder of mechanical mathematics and was a close friend of Plato. He sought to combine real-world experimentation with the Pythagorean theory. He solved the doubling the cube problem using the theory of proportions, showing how to, given the segment A of the cube, construct segments B and C. Archytas also applied this theory to musical harmony, which enabled him to define intervals of pitch in the enharmonic scale, in addition to those already known in the chromatic and diatonic scales. Archytas was inspired to discover and experiment mathematically because of his love for music and octaves. He constantly responded with wonderment and awe at the amazing patterns he found in music, which is an excellent habit of mind for anyone making innovating discoveries. To better understand the concept of geometric progressions, one needs to understand arithmetic sequences. In an arithmetic sequence, each number is found by adding a constant value to the previous number. This constant value is called the common difference. For example, take a look at this number sequence. Can you guess what the common difference is? It's 2. Each number is 2 more than its previous. The definition of an arithmetic sequence is literally any sequence that has a common difference. This is an arithmetic sequence. This one isn't. Once upon a time, in 18th century Germany, an elementary school teacher asked his class to find the sum of the counting numbers 1 through 100. He was astonished when one of his pupils, Carl Gauss, answered the question seconds later. Gauss went on to be one of history's most influential mathematicians. To answer his teacher's question, Gauss used an arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. Using this equation, Gauss was able to solve the problem quickly. N refers to the number of terms, which is 100. A1 refers to the first term in the sequence, which is 1. D refers to the common difference, which is also 1. This comes out to be 5,500. As mentioned before, a geometric sequence is a number sequence where each term after the first is found by multiplying the previous one by a constant value. This constant value is called a common ratio. A geometric series is the sum of the terms of a geometric sequence. In a geometric sequence, the common ratio can be represented as r. The first term in a sequence can be referred to as a, or ar to the 0 power, since it's being multiplied by 1. The second term can be referred to as ar to the first power, since it's being multiplied by r. The third term can be referred to as ar to the second power, and the fourth ar to the third, followed by ar to the fourth and ar to the fifth, and so on. Now, let's use this equation to solve a somewhat lame story problem. Shira receives a joke in an email that asks her to forward it to 4 of her friends. She forwards it, then each of her friends forwards it to 4 of their friends, and so on. If the pattern continues, how many people will receive the email on the 9th round of forwarding? 5 emails are sent in the first round, and there are 8 rounds of emails. So, A1 equals 5, R equals 5, and N equals 8. There will be 488,280 emails sent after just 8 rounds. Geometric sequences are incredibly prevalent in our world. From viruses to viral videos, they surround us in ever-increasing numbers, growing until they reach their final term.